The integral of xn is, as you can see on the screen. Essentially, we're finding the antiderivative and then finding the unknown c value. So here we have an example. We need to find the integral of 3x to the power of 5 dx. So to begin with, we do find the antiderivative. So the 3 remains. Remember, the power increases by 1, so instead of x to the power of 5, we now have x to the power of 6, but we need to put the fraction of the new power out the front first. So we get 1 over 6, x to the power of 6. We have some sort of c constant that we don't know, and now we can simplify this out. So 3 times 1 over 6 becomes 1 over 2, which we can convert to x to the power of 6 over 2 plus c. So again, you need to find the antiderivative. So what we do there is, remember the 3 remains, we times it by the new power. In this case, it went from 5 to 6, so we times it by 1 over 6, x to the power of 6. And then remember, you need to add that constant on the end, that unknown. Now, in some questions, you'll be given a point, which you can use to find c, and we'll show that later. So here we have another one, and we do the exact same thing. So I need to find the antiderivative. So we start with that h to the power of 7. There's nothing at the front, so all we get is 1 over 8 h to the power of 8. Because remember, the power goes up, and that new power is the fraction out the front. The 5 gets a h, so we write 5h, and then we have our unknown c constant at the end. So we can simplify this down. We get h to the power of 8 over 8 plus 5h plus c, and we're done for that one. So we're looking at the next one here. So it's the exact same thing. We need to find the antiderivative. So I'm going to keep the c out the front, and we're going to multiply it by the new power. So x to the power of 5 becomes x to the power of 6, and 1 over 6 out the front. X to the power of 4 becomes x to the power of 5, and 1 over 5 out the front. Now the 2 remains. Now x to the power of 3 becomes x to the power of 4, and 1 over 4 out front, and lastly we write our plus c. Now we look at simplifying it. 6 times 1 over 6 essentially cancels out, so we get here x to the power of 6 plus 1 over 5, x5 can be simplified to x to the power of 5 over 5. 2 times 1 over 4 becomes 1 over 2, so we get x to the power of 4 over 2 plus c. Got to remember that c. So we're going to look at a word problem here. We have, for a certain graph, its rate of change of y values with respect to x values is given by r equals 3x squared minus 2x plus 1. Alright, and if the graph passes through the point -1, 3, find its new equation. So at the moment we've got a rate of change. We want to go back to find its antiderivative. So we have r equals 3x squared minus 2x plus 1. Essentially what we're trying to do is find the integral of 3x squared minus 2x plus 1 dx. And to do that, we find the antiderivative. So that 3 will keep out the front. My x to the power of 2 becomes x to the power of 3. So we get 1 over 3 here. The 2 remains out the front. We get our x becomes x squared. So we go 1 over 2 x squared. This becomes an x, and then we write plus c at the end. All right, so let's simplify that down. This cancels that out. 2 times 1 over 2 cancels that out. So we're left with x to the power of 3 minus x squared plus x plus c. So at this point, we now need to substitute our point in. So we need to substitute minus 1, 3 in. Now remember, this is your x value, this is your y value. So what we get is we get y equals x cubed minus x squared plus x plus c. Now we put our values in, so we get 3, not -1, we get 3 equals -1 cubed minus -1 squared plus -1 plus c. We can do some rearranging, so we get 3 equals -3 plus c. We plus the 3 to both sides here. That cancels that out. And we get c equals 6. So we need to write the new equation. So the equation is, and we just write y equals x cubed minus x squared plus x plus 6, because that c became 6 there. So to recap, when you're doing this, you're essentially finding the antiderivative and remembering to add the c on the end, that constant, because we don't know what that is. Now, if you're given a coordinate, you can substitute these in to find that unknown c and get the original equation.